So our question, our one and only question, a rather simple question is, have you read the book, The Goal? And the answer is either yes or no. If you could let us know if you've read the book, The Goal. Give it a few more seconds here. All right, and for everybody's sake, and for Paul's, today's results, about 13% of our attendees today have read the book, The Goal, with a large majority, 87% of our attendees have not. And I suspect Paul will promote that book at some point in the session. With that, I do want to introduce Paul Krier. He's the Vice President of Components with Villaume Industries in the St. Paul, Minnesota area. He comes to us from outside of the component manufacturing industry, but has been with Villaume for a little over a year now, I believe. Last week, he had a great part one of this webinar series looking at lean concepts outside of the industry. And today, he's going to share some great information on how he is approaching lean within his component manufacturing company in Minnesota. So with that, Paul, I'm going to turn it over to you.
All right. Thanks, TJ. I really appreciate everybody's time and attention today, and really look forward to sharing some of the things that we're doing here at Villaume Industries. Share some of the things that we're doing here at Villaume Industries to improve our processes, both in the office and in the shop floor. Most of the examples today will deal with the shop floor and how we think about implementing lean and some of the tools that we can use inside of a lean transformation. A lot of these things really work best in combination, and because it's not a one size fits all inside of this. And so when you're looking, reading, looking at any number of things out there, try to incorporate how it relates to you, because there's not a lot of books out there as far as lean implementation inside of the component industries. So when you're reading a book or watching a video, the goal is to try to envision how these tools are being applied in this place and how you can apply them inside of your particular plant. Inside of some of the examples, we'll show you how we're doing some of these lean implementations right now. I kind of went over who I was last week. Married, a few kids. Quick note, I did earn a bartender degree, bartender certificate when I was in college. Bartended for 3 years, just kind of a fun fact rather than just going through the same old from last week. So even if you don't get much out of this, you can always stop by our facility and I can make you a nice drink after. One of the big things that I stressed last week was the training and development piece. And training and development, as far as driving continuous improvement, has to be in what I look at as two main things. Education, as far as developing people how to think and how to see and how to implement it. And then the second part is the actual application of those tools and processes that we've learned about. Inside of Villaume Industries, we've done a lot of training, and I've taken time over the last 2 years and done a number of things. I've shown the toast video, the goal video, 5S for your garage, many PowerPoints, and I also had my leadership team go through reading The Gold Mine. It's also another great book about lean implementation. And then I've also taken a number of the groups through what's called the Lego game and just teaching them a hands-on experience as far as how to look at and implement lean implementation inside of the shop. So during that time, we've done a number of Kaizen events. We've done a lot of just do it's, but just really making the continuous improvement effort very interactive for the team. And a lot of times, like the toast video, I've shown numerous times because of the turnover and just re-showing people how to drive lean in the organization. Last week, I also talked about the three big things as far as how do we eliminate waste or how we eliminate waste in a business. One is MUDA, as that's the 7 or 8 forms of waste. MIRA, the unevenness. MIRI, the overburdening, and just really the stress of the world when you look at that. And during today's implementation, we're going to look at all three of these in different segments here at Villaume Industries. The other big thing is that we're trying to reduce the time from the cash to cash cycle, from when we get an order to when we actually get paid. And using these tools and using these processes allow us to reduce our lead times, reduce our throughput times, so that we can turn out more trusses or wall panels, whatever it is that we're building inside of our facility. Just making sure that we are trying to reduce the time from when we get an order to when it gets out. This really drives the continuous improvement efforts. One of the things that when I first came into Villaume Industries, they had been doing this activity for quite a long time. One of the goals that every plant and every organization should look at is trying to make a visual system. And what they did is they have a CAN process. And again, this was done way before I started. What we have is 3 different saws that we get components that actually make a truss. Inside of the production office, an order will go to each one of those saws and it will have 2 red cans. And so when it comes off of our component saw or a linear saw or a miter saw, for that order, it will get 2 red cans. So that when it's in the queue, when it's in the buffer before it goes to the table, the water spider or the foreman has an easy visual to take the 2 red cans from the component saw, the linear saw, and the miter saw and move it effortlessly to the table. It's a really easy system that allows for a person to quickly identify which components, which parts go together for a particular job. Here we have some of our carts. One of the big things is that there's a lot of physical and mental stress, that overburdening that comes along with building trusses. And one of the things that we've done is we've put a set of trusses approximately 12 to 14 inches above the original carts. This allows the person or the operators that are working on the table to easily move the lumber from the cart to the table. They don't have to bend down putting it on the cart, and they don't have to bend down taking it off the cart, putting it on the table. One of the main drivers to this is the reduction of batch sizes. The carts themselves probably were originally made for large batch processes moving throughout the shop. But again, before I started, they had a really great team and a really team that wanted to continuously improve, and they learned through another truss plant that reducing the batch sizes allows trusses to move quicker through the operation. So they reduce the batch sizes, and then once you reduce the batch sizes, you could see that you could actually make an improvement of the ergonomics moving the material onto the cart and off of the cart. And one of the other great side notes of this is that you can always learn from somebody else. Stealing best practices from others is a great way to drive the continuous improvement efforts inside of your own plant. This was suggested to me as far as how another plant built their carts. We modified it and made it useful to our operations. Our air guns. Air guns, when I first came in here, were all over the floor. We had cords that people were stepping on. We were moving carts over them. You went throughout the shop, and all you would hear is air flowing throughout the shop because of these the hoses being run over and being beaten up. In the second when we went to having counterbalance air guns, I originally put 3 in, 2 on the bottom cord and then 1 at the peak. This, I thought, we have 3 people on a team, so everybody would have a gun. However, the person at the peak was always having to pull his gun too far to either ends of the truss. So what we did in taking that next step is that we put 2 on we have 2 on the bottom, and now we have 2 on the top, 1 on each side of the peak. Actually, just before I came in here, one of my operators said that he'd like to have 3 on the bottom, making it a little bit easier for him on the shop floor. So we're actually going to try 3 on the bottom and 2 on the top. Over here on the right was a new thing that I created, kind of a sample. This is the one and only sample for a staple gun. One of the physical stresses of being on the table is the constant bending down, putting plates on, or stapling the lumber together. In order for us to try a new way so that the operator didn't have to bend down, I created an extension on one of the air guns so that the person could easily walk on the table, stapling the corners instead of having to bend down. I tried it, it worked for a little while. However, the team themselves did not care for it, so we went back to just having a gun hanging in the air. Now, these are the things that you just got to try. If you come up with ideas on improving the system, go for it. You know, it cost me a couple $100 to make this extension. We tried it out, it didn't work. Now I got a great tool that I can show people in my office. One of the other things that we're constantly looking at, or that I constantly look at, is plates. Plates have a tendency to move all over the shop. You know, they get on the floor, they get underneath the table, they're spread all over the place. And as everybody knows, they're sharp. They cut hoses. There's all kinds of problems with having the plates uncontrolled. So what we've been doing, what was our first step in making it a little bit more controlled, is you can see our new floor table. We decided to get them organized. One, we pick our plates so that the operators themselves get all of the plates, all of the special plates delivered to them. Some common plates are at the table themselves, but a cart will come. When the lumber comes, a cart comes with the special plates. Number 2, we put these trays on the table so that the plates that are on the table are controlled. And number 3, we learned from other representatives inside of the industry of having the person on the B side pass the plates to the person on the A side. Now, the second part of this is that when we looked at plate organizations on the table themselves, initially we didn't have anything. The second step, we had stationary trays in the middle of the tables, in the middle of the clamps that hold the cords in or hold the trusses together. The third step inside of this process is that we actually magnetized the trays so that the tray actually moves inside as close to the operator as possible and moves back out of the way once the clamp is released. On the left-hand side, this is our new rail rider truss table, and we have some metal trays in the center there that move to the A side and the B side. And over on the right is an old Chrysler that has, again, some plates that move from the A side to the B side. Also, some really quick things, and I know a lot of you guys do this out in your yards. We got a lot of pushback from our internal team out in the yard as far as putting railroad ties down to put the trusses on the ground. They always wanted to use blocks. They never liked the railroad ties idea. However, once we actually installed the railroad ties out there, it significantly improved our forklift operators' efficiency as far as putting trusses away in a stack, as well as taking them off and putting them on the trailer. Over on the right, We also had a lot of blocks inside of our floor tables. It was a constant battle of managing all these pieces of 2x4s that were cut to different sizes. What our former maintenance manager came up with is an actual, a block that's universal. So when we have a 24-inch or a 19-inch, 19.2, whatever the size of the floor truss it is, it's easily movable for the operator to change the size so that when the clamp comes down, it is in the exact position that it needs to be at. At our block tables, we had a lot of injury. We still nail our blocks on either end of for our floor trusses. We created a system that has eliminated the person from getting injured with accidentally nailing their hand. It's kind of awful. But I'm looking for ideas. One of my teams is looking for another block table to be produced. And if people have other ideas on creating a block table, we'd be more than happy. Send me a picture. I'd love to see it. But it allows, the big thing here is that it took away the safety concern inside of a person putting it on its side and the nail going in the wrong direction. Shadow boards. One of the things that we did over this winter is update all of our shadow boards. Shadow boards are great. It allows for a very visual of making sure that you have all the tools that an operator needs to do the job that they have. But if you look over here on the left, you can see a very outdated shadow board. It has handsaws in it. When was the last time you've seen somebody use a handsaw? I actually told everybody if somebody wanted to take them home, they're theirs. It's a gift from me to them. So what we did over this winter is that we redid all of our shadow boards, putting them in the location for the operators to use them efficiently. And you can see that picture over here on the right. However, like always, with any shadow board that you have, it needs sustaining. Again, like I talked last year, in a 5S organization, don't focus on the 3 S's only. You have to look at standardizing and sustaining the improvements. This happens no matter where I've been inside of my any company that I've been at, making sure that people are following the systems that you've created, because you've created these systems to make their job easier, but a lot of times they need reminding and they need to be held accountable to make sure that things sustain over time. Last week, we also talked about standard work, and this is one of the foundational pieces of any lean company. Last week, I showed an example of a very complex, very difficult standard work inside of how it was all documented line by line, what they were supposed to be doing. Working with Greg Dahlstrom, our IT manager, and our operators, we have created our own YouTube channel that give people an understanding of how to do the work that we want them to do. The work that we ask people, whether they're starting out etching or replacing a blade on a miser, is very important on the steps that they do the work. And in this day and age, watching videos, going back to see it over and over again, allows us to standardize the work in which that we are trying to do. Now, we're not trying to do every workstation or every job all at once. We have an internal goal, or Greg has an internal goal of 1 video per month or per week. And he has really started to drive a lot of improvements inside of our operations and really standardizing our process with the help of our operators to show people how to make sure that they do it in the proper way. We also have fun with it. We have Servo Steve up top there talking about how to manage the servos, and we have Miser Mike down there on changing a blade. Developing a project. when I've been doing lean implementation throughout my career, I've looked at, I developed this process of visualizing, simplifying, standardizing, and sustain. And when you're looking at project management or a continuous improvement project, here we have the different components. We have roof trusses, we have floor trusses, we have wall panels. Inside of our example here, we're going to focus on roof trusses. Then when you look at roof trusses, you know, just a very basic thing, you got small, medium, and large. Inside of our example, we're going to look at the medium and large roof trusses. Last week, we talked a little bit about takt time, okay? Takt time is the beat of the customer. When you're looking at takt time allows that you take their demand and convert it into time. How much time it takes to be able to produce the work that's necessary. So inside of our quick example here, the average daily demand of a customer is 24,000 board feet per day. We'll simplify it to 24. We look at the available work time of one shift, and the work time is work hours minus the planned downtime. So you have an 8.5-hour shift, you take out breaks and lunches, you have 480 minutes. So over here on the right, you have 510 minutes. You take away the 30 minutes of the breaks and lunches, and then you divide it by 24, which is your average board feet per day, and you get to 20 minutes, and that's your takt time. That's saying that you have to produce 1,000 board feet every 20 minutes throughout your value streams. If you look at it as an hour basis, you'd have to produce 3,000 board feet every hour. We have been very successful or very fortunate to have Greg really help us drive a lot of our metrics or our systems to be able to track output inside of our organization. We can look at shift by shift, we can look hour by hour, we can look at table by table to see how well we're doing as an organization meeting our goals. So inside of my mental math, inside of our operations, it's like how much are we producing over this hour, these 2 hours? And then I can get with our production manager who is also looking at the output, and we can figure out what we need to do to increase output if necessary if we're not hitting those goals. If you look at overtime inside of takt time, you have a 10-hour day. Your rate goes up to 23 minutes per 1,000. If you have 30,000 board foot in 8 hours, it goes down to 16 minutes. The big thing here is that you need to set goals for each of the tables. A lot of times we have different tables that we expect different output. It has different equipment, has a different team. We want to get it standardized as much as possible, but setting a goal that's realistic and effective is one of the big ways in making sure that we're producing what we need to do on a 20-minute cycle or an hour-by-hour cycle. Develop your teams, 3 per table, have a water spider. A water spider is just a person that's filling gaps when a person goes to the bathroom, moving material, making sure that the people at the table are not having to leave and reduce the output. If they're missing a plate, the water spider is the person that goes to get that next plate and bring it back to them so everybody can continue to produce. You know, again, tracking regular intervals by hour. Currently, we use the shop system. We have a great way inside of our system that we track output as far as the management system. We're able to track an hour by hour, or day by day, month by month, whatever it is. But one of the big things is also to have the teams track them. And that's one of the gaps that we have internally. Also, use strategy math. It doesn't have to be perfect. These are guidelines and guidelines to help you to be successful. In looking at scheduling, a lot of times we have variation inside of our scheduling. Here we have a system, we have a 3-week system. It's the week before 4th of July, the week of 4th of July, and the week after 4th of July. So we have week 1 at 22, week 2 at 17, week 3 at 33,000. We have an average of 24,000 board feet on a daily basis. Our capacity that we've seen over time is that we can produce approximately 20,000 board feet per day. So what do? So we need to track our board foot output on a regular basis. We need to track it daily, we need to track it weekly, with and without overtime. We really need to understand what our internal capacity is so that we can plan and meet our customers' demand. Because inside of the situation, a lot of times we get into is that we're running overtime the first week, we reduce our hours the second week, and then we really crank back up the third week. Really trying to do everything that we can. We know in our system, in our process, we try to stay 2 days ahead of the customer. So our goal is that anything that's needed on Friday, it's being done and completed on the Wednesday. So we have some time to be able to meet that customer's expectations or to change shipping. So inside of this process, we start running 20% overtime during the week. Okay, we get up to our 24,000 board feet per day, we start to cruise. Our big concern is that big peak on that Thursday. What are we going to do? How are we going to manage through it? And running that overtime as much as we can during that week, and potentially working with the customer on how to smooth that out is a big focus for us internally. Secondly, the week of 4th of July, we reduce some of that overtime. We reduce it back so that we are putting inventory in the yard. We are building inventory at this time. We haven't gone back to 6-hour days. We haven't gone back to 8-hour days. We're just reducing it a little bit so that we're not producing at the rate of just overloading the yard. Then on that third week, we go back to the 20% overtime, getting back up to 24,000 and really driving home so that we can meet our customers' demand that week after 4th of July. And as we talked about before in the first couple of slides, we're trying to eliminate unevenness, okay? The goal of this is to manage our value streams, to manage our process so that we create flow, we create evenness as far as material moving through our shop. And by having 20% overtime, 10%, 20%, it's a very even flow inside of our process. What else can we do? We can throw in some Saturdays if necessary. We can hire some more. And as always, drive continuous improvement inside of our shop. I'm going to go through this pretty quick, but here's another quick example of how you need to look at your system itself. In an uncontrolled process, here we have a quick visual of a value stream. It takes 16 days in a first in, first out system as far as how to move material through our shop. We have 10 days of raw materials. It takes a half a day to go through our saws. We have 2.5 days worth of whip, another day through the tables and the stackers, and we have 2 days in the yard. With an uncontrolled process, and really watch the whip area, because the constraint of the process, and we're going to get into this a little bit more in a little bit, the tables themselves can only produce so much. But if the saws can outproduce them, all of a sudden they are working hard because the guys and gals that are on the saws themselves really want to work. they have the opportunity, they're going to continue to move and produce inside of the operation. And you can see on the bottom corner of the slide, as the saws are left uncontrolled, the inventory is building and the days that it takes for material to move through your operation is significantly increasing. Lastly, we keep going through the process. There is a ton of double handling. There's a ton of changes in schedule. It is a very uncontrolled process at the end of these 10 cycles. You've gone from 16 days up to 23. You're probably running a ton of overtime. You're probably doing a lot of double handling. In a theory constraints in a drum buffer rope system, you have a constraint, your drum of the process. This controls the output. You have two buffers, one in front of the customer and one in front of the buffer, that allows the buffer to never run out of material. Then there's the rope back to the raw materials. It makes sure that material does not get released unless the drum, the constraint of the operation, produces product. And so here we create, in our operation, the drum is our tables. We have our two buffers. We have the buffer in front of the customer to create even flow to them. And we have a buffer in front of the tables to make sure that the tables never run out of the material. Lastly, and the most difficult part of this is the rope back to the lumber, the raw materials. What you need to do is make sure you have a goal for your buffer. And in our example here, it's 1 to 2 days. But you need to create a wall that stops material or stops orders going from the saws unless material is being produced off the tables. Same example, same kind of flow inside of the operations, 10 days, half day, 2.5 days, and so forth, 16 days. After the first set, we've reduced some of our inventory because our buffer, we want to stay between 1 and 2 days. We keep inventory levels low inside of that buffer in front of the constraint. At times it may overproduce. Something happened that an order got released before orders came through. We bring it back down. We're continuing to manage it. Very easy for your production team or your water spider to move what's required to the table. You get better at the process, and all of a sudden you're creating your first in, first out system. Instead of moving carts all over inside of your operations, we're having a first in, first out flow through the operations. So in the end, inside of Villaume's operation, in the summertime, we have a 1-shift buffer. Okay, in the wintertime, we have about a day. This allows us for very quick turnover inside of our operations to meet our customers' expectations. So from when it gets cut to when it gets put out in the yard, in the summer, it's about a day. In the winter, it's a shift. And in the winter, it's about a day. The big things that you need to do is always look at minimizing batch sizes, because as they always say, what is the first board doing when the last board is getting produced? It's just waiting. And one of the waiting things is one of the waits. So you always want to try to reduce your batch sizes so that the turnover can happen a lot faster. One of the other things is that we have a buffer probably at times bigger than what I want. And that's due to equipment uptime. Over the last 2 years that I've been here, we've really spent a lot of time on improving the uptime of our equipment, because buffer, you need a lot of buffer a lot of times if you have equipment problems. So when you're looking at creating that size of your buffer, look at the capability of the material or of the equipment that's producing that buffer. Because if you have a lot of downtime, you might have to have an increased buffer, But as that equipment gets better, start reducing it, and you'll see your throughput really start to increase. Some of the theory constraints questions, what metrics do we use? The metrics that you use will drive your behavior. In the book, The Goal, they talk about throughput, inventory, and operating expense, okay? In very quick terms, it's how many board feet you're actually producing. How much inventory do you have inside of your value stream and inside of your raw material and finished goods? Controlling your inventory allows your throughput time to be reduced and improves your cash-to-cash cycle. Operating expense is how much you're actually working inside of the operation, how much it costs. Basically, if you want to do it even simpler than that, is just look at how many operators it takes to be able to produce the throughput that you actually need. A great older book, The Goal is very well known. It's a must read for anybody that has a batch type of process inside of in any manufacturing operation. The other two books that I highly recommend, it actually gives more data, more meat associated with it. And it's a really older book and it's not in print anymore, but you can get it secondhand, is Synchronous Management, Volume 1 and Volume 2. It gives a lot of detail that The Goal does not. The Gold Mine, also another book, The Gold Mine also is a great resource for your team. Next steps is really quick visual of what we have inside of our buffer. Over on the right, Greg has created another system and process that's easy for our foreman to quickly look at how many board feet we have inside of our buffer. Inside of our operations, making sure that we continue to take carts out of the system to reduce that throughput time, just increase that turns. We always will look at equipment uptime, and then making carts designated for particular areas. Because at times, carts will get overused for floors or overused for roofs, and then we don't have the right balance inside of our operations. Equipment. One of the big things on equipment is that I've been very impressed with our equipment manufacturers inside of the component industry. All of the manufacturers, when you go to the BCMC show, are not just creating a better saw, they're thinking about ways that it makes it easier for us to have less people and for it to go through the process a lot simpler and easier. Old equipment is very important. If you read the book, The Goal, they talk about getting an older piece of equipment inside of the operation to help elevate their constraint, elevate their constraint, I guess I can't remember the right term. But some of your old equipment still allows you to produce if it is part of the constraint. You may have a table that's still a manual table. Every once in a while, using that manual table to offset some of your modern jigging system just allows for more output, more throughput to happen. And again, going back to the equipment, it's tough to implement lean or theory constraints with regular equipment downtime. Having a good maintenance team, having a good production team that is doing their operator care, managing the process really helps. Here's some quick results inside of Villaume. We've been safer. We're doing a lot of 5S. We're keeping our operations clean. We're creating shadow boards. We're improving the process that we're doing our jobs. They're not all perfect. There's still a lot of improvements that need to happen, but we've had a lot safer system over the last couple of years. Productivity, we've had a double-digit increase in productivity year over year. Our output increased by 20%. This past year, we're again looking for double-digit growth in our board foot. We've increased our full-time operators. One of the things that that's really important is the hiring piece. We've really changed our focus in hiring from using contingent services to hiring direct. And one of the great things with doing that, we've increased our full-time operators by 50%. And when you have 50% more trained and experienced operators, you're just a better plant. It's the stress of the operators themselves is reduced significantly, along with your foreman, along with your production managers. Our designer, I didn't focus a lot about it, but we've done a lot of lean implementation, a lot of improvements inside of our information flow. One of our designers that's been around for 20 years, he said this past year was his best summer as a designer. We had a 20% increase in output, and he felt less stress. He was not working weekends. He was not working crazy hours. He had his best summer as a business. Again, cleaner and organized. We've gotten customer awards this past year for how well we've serviced them. There's still a lot of schedule. We've done a lot of changes in schedules and a lot of changes in sales. I look at the complete value stream, cash to cash cycle from our sales team. I talked to Tony, our sales manager, our design manager at Chris, our production manager, also another Chris, our shipping and receiving. I work across the value stream to make sure that each team members understands their responsibilities. Still need improvements. We still have issues with some of the creating pull. Sometimes we do over inventory. We still have a lot of scheduling changes, and it's tough, but the big thing is start, get going on it. We could do more with reducing batch sizes, drive more first in, first out. Throughput consistency, making sure that we're doing seasonal changes up here in the winter weather, just making sure that we're ahead of the game on our seasonal changes, and continually hire throughout the value stream. Making sure that you have the right people in the right places really drive better results inside of the organization. Like I said, it's from sales to shipping, everyone is involved. A great book that you can look at is The Gold Mine, along with The Goal and Synchronous Management. All three books work really well together. There's great YouTube videos out there. There's also videos that you can purchase. And, on the education, just ask others. I mean, I've been very, very impressed inside of the industry at how open other people are at as far as sharing information. And the application side of it, just do it. Using the tools that you've learned through reading the books, watching the videos, getting some of that continuous improvement knowledge, and just going out there and doing it. A lot of the changes that we've done, the first time that we made changes, it was not successful, even the second time. So making sure that you're trying things so you can go through that continuous improvement cycle over and over again is really key to your success. Make a difference, okay? Connect with teams. Here's Chino, one of our great operators. Giving your team goals. They like goals. They may not say that they like goals, but if they're hitting them on a regular basis, they feel good. Set goals, make them difficult, but make them attainable. Train them, support them, listen to them, work with them. The other day we were having a meeting with first shift, and Chino said at the end of the meeting, hey, these conveyors at the other side of my finish roller, they're all broken down. You know what? He's right. I've overlooked that for 2 years. We're now, with our maintenance team, building a better conveyor system coming out of the finish roller so that Chino can be successful. And, like I said, improve it. And, it's hard work. Simplify it as much as you can for them. Make it easy. Make it a good day's worth of work. And questions?
All right. Thank you, Paul. That was certainly a wealth of information that we certainly appreciate. Yes, I guess anyone on the webinar this afternoon, if you have any questions, please direct them, type them, send them to us, and I'd be happy to make sure I ask Paul here this afternoon. We do have one question that came in from Ken. When you were talking about production, more specifically, and the various metrics that you look at. But his question is, what's your opinion, Paul, on 3 versus 2 man teams and all of this?
What we've seen is that 3-man teams are much more effective on getting board footage out on medium to large trusses. Okay, when we've looked at 2 to 3-man teams, the person that's on the floor, if you had designated of duties, the second man is up on the table and the first man is on the floor. There's just a lot of work that's associated, a lot of physical stress on that person on the floor, getting that material up there. And there's a lot of downtime for the person on the table. If you decide to take the person if you're just a 2-man team and move them to the floor to help get the lumber up there, then all of a sudden you just have too much work associated with getting the boards in the right places. The third man on the table, if you have 2 guys throwing lumber up there, the third man is putting all the puzzle pieces, as our production manager says, putting all the pieces together while the other 2 guys are getting the puzzle pieces on the table. In smaller trusses, having 2 guys only, because then they're too much on top of each other. There's not enough work content in doing smaller trusses with 3 people. They're on top of one another, and your productivity is just not there.
All right, thank you, Paul. Scott is wondering if you can share your manufacturing plant's total board feet per hour numbers, and then how about your safety dart rate?
Um, I'll say that we're doing during the summer months, we're doing well over 20,000 board feet per shift. It's growing significantly, but we're doing upwards of 20,000 board feet per shift. In regards to our dart rate, it gets a little confusing or different inside of our operations because we also have a pallet division inside of Villaume Industries. We do pallets, crates, and cores for industrial customers. I would say that last year we had 10 recordables. And we've worked really, we've worked diligently over the past winter to try to minimize and reduce some of those injuries. So.
Okay, thank you, Paul. Joyce has a question. Joyce, welcome back. What shop system are you using to measure hourly throughput, Paul?
Greg has used we're in MyTech, and we use both management and MVP to manage our overall flow through the operation. And Greg has created some internal systems that are very easy for us to pull up on the web for us to manage our overall throughput board footage per hour. So he's been able to take the information from MyTech and then create graphs that we're able to follow the output either by a jig or by the overall shift.
Okay, thank you. Keith has a question. Notices that you put a lot of focus on reducing batch sizes. Why is this? He's wondering, what problems were you facing with larger batch sizes?
So this is one of the key pieces in reading the goal and doing the theory constraints and trying to reduce your batch sizes. The first board let's say it's coming off the saw. Okay, so we have a servo that produces that first board. And one of the big things in any lean organization is reduce the throughput time through a process. And when that first board comes off, it gets set on the cart. Then if you have 100 more boards, top cords and bottom cords are coming out for that particular batch size, that first board is not doing any value add until that 100th board comes out. It does not get moved until the 100th board comes out. Now, if you reduce it to 50, cutting it in half, it's still a good size batch size. That first board can get moved inside of your buffer or closer to the table inside of that process. So you reduced your throughput time, your process batch, by half in moving that cart through the system. And it's not saying that you may have, and this is just fine as well, you may have a batch of 100, but you may have 4 process batches of 25. So you may have a cart of 25 that moves in, and then another cart of 25. So yes, you have some more handling associated with it, but the rapid flow that turns the inventory allows throughput time reduction through the process significantly, and it also drives increased throughput. Now the goal is again to minimize the buffer inside of that process so that the throughput time can be reduced even more. So reducing batch sizes and reducing that buffer allow for reductions in throughput time and increases in throughput because you're not touching it as much.
All right, great. Thank you, Paul. Throw it out there. Any other questions that anyone may have for Paul today, please let us know as we're looking for some additional questions to come through. So we can just give it a couple more seconds, see if anyone has any final thoughts. But Paul, look at this. Joyce, another question. Have you ever studied how much more scrap is caused by smaller batches? Paul.
No, I don't know if you would have more scrap. It doesn't, the way that I would say it is you'd actually have a potential for more scrap with larger batches because you would identify a defect later in the process. If you had a batch size of 100 and the saw was off 1/4 of an inch, all 100 of those would be off. Now, if you had a batch size of 50, then you only have 50 of the pieces to be bad. Actually, reducing batch sizes drives improvement in quality more than it drives a better quality than having larger batches.
All right, thank you, Paul. Leif is wondering, do you measure BFD per man hour? And if so, what type of rates do you see?
Great question. We have trouble a lot of times as far as getting accuracy from our team leaders in putting in their how many teams or when they actually start a job inside of the system. So we are constantly battling our team leader, our table leads of putting information in. So we have difficulty giving a lot of accuracy to that productivity measure, having a productivity measure like that. One thing that I do measure is how many people that I have on each of the shifts and what amount of board foot that I expect out in a particular day. So if I have, and again, I'd have to look back on my numbers of how many board foot and how many people I had that day. It doesn't give me a specific table or a specific saw, but it gives me a holistic view of how well we're doing well before the P&L comes out that tells me, how many dollars that I spent in labor versus how much sales that I got. Having a rule of thumb for your team is just, it allows the group to kind of see what you have. If you're doing 20,000 board feet in a shift and you have 30 guys or 40 people, you kind of look at getting some standards and then creating goals as far as increasing that output or reducing the amount of team members you have on a shift.
Okay, thank you, Paul. And our last question I'll throw out here today is, do you think counterbalanced air guns would be any good in a wall panel line?
So I'll say this: we don't do wall panels at Villaume. We're only a floor and roof trusses. I have some ideas, but I would say one of the big things is getting those hoses off the floor. They're trip hazards. They're difficult to move around with other equipment. I would say try it. I have seen some other truss plants that just actually have a hook instead of a counterbalance, that they actually just have something above their head that they can hang the gun on. So again, that the cords are not on the floor. But not having a wall panel plant inside of our operation, I'll pass on answering it. But the safety piece, I would say overall, yes.
All right, great. Thank you, Paul, for answering that, for your questions, and for your presentation today. We certainly appreciate it. If you could go to the next slide for me. I do want to just put one last plug in for everyone still on the line. Our part 3 of this Lean webinar series is going to be next Tuesday. We hope you will join it to learn a bit more from Victor Sanchez, who is with Trussway, as he'll dive into this issue and look at what he's looking at and dealing with on his end there at Trussway in Texas. Of course, you can get more information about everything we're doing at sbcindustry.com, and make sure you subscribe to our various publications. But with that, I want to thank you all. And again, thank you, Paul, for today. And with that, we will conclude today's webinar.
Thanks, TJ.